Hi, welcome back to CSE 545 Software Security. In this video, we will talk about x86-64 assembly. The goal here is to quickly walk you through x86-64 assembly as a language so that you can read and understand the instructions. This is definitely not the correct way to learn architecture, nor the complete tutorial for x86-64. I'm hoping that this video will cover the majority of the content of x86-64 that is needed for reverse engineering, or say for this course. If there is anything missing, please let me know. I will show you in our Thursday's class or answer your questions online. Since the goal for us is to read x86-64 assembly properly and understand the meaning, let's just start to read them. While we're reading those instructions, I'm going to show you the semantics of those instructions, as well as essential contents that you need to know in order to understand them. So let's start. The first instruction that I'm going to show you is push RBP. I'm pretty sure that many of you have read these instructions before. And in this instruction, as I showed, there are two parts, push and RBP. Push is called mnemonic. It means that it is the operation, and we use this push mnemonic to represent this operation of push. RBP is the operand. And here it means that we want to push this operand into the stack. You might wonder, what does it mean by register? Register is a location that the CPU is able to visit quickly. And we can just consider register as a CPU predefined variable. For x86-64, there are 16 general purpose registers. And you can access them with different length. Here I show the 16 registers and also the representation for each of the register with a different length. For example, for register RAX, if we want to access the 64-bit register, we can represent it as RAX. However, if we only want to read or write the lower 32 bits of RAX, we can use EAX instead. Similarly, if we want to access the lower 16 bits, we can use AX, and for lower 8 bits, we can use AL. Actually, for higher 8 bits, there is also a notation. It's called AH. So this gives us a very convenient way to access each of the parts of a register. In terms of a stack, as I mentioned, this is a push instruction, so it has to push to somewhere. And the CPU, there is a design of stack. In this data structure, the first element's in, the last element out. So if you push a value over there, later on, if you do pop, the value that you just pushed will be the one that will be popped out. Usually for stack, when we push, it's going to push the low address of the stack. For example, if we push RBP, we're going to append the value of RBP to the bottom of the stack. And this is the way that we push RBP into the stack. After pushing RBP, the value of RBP will still be stored in RBP. However, later on, if we're going to substitute RBP with other value, this value will disappear. But since we already pushed RBP into the stack will remain the value. All right, that's pretty much for the instruction push RBP. Now let's move on to the next instruction. Let's look at this instruction together. Move RBP RSP. And let's start with the structure first. Different from push RBP, this instruction contains three parts. One, again, is the mnemonic for the operation. And the other two parts are operands. So there are actually two operands over there. One is RBP and the other is RSP. This instruction means to move the value of RSP to the value of RBP. After this instruction, both RBP and RSP will be in the same value, which is the one that comes from RSP. You may find this flow a little counterintuitive because we usually write from left to right, but actually here when we move from right to the left. Actually, there are two different kinds of syntax that we can use for the x86-64 instructions. One is called the Intel syntax. This is the one that I just mentioned before, which moves the right-hand side operand to the left-hand side operand. The other syntax is called AT&T. What it does is just the opposite. It moves the value from the left-hand side operand to the right-hand side operand. If you look at the machine code of these two instructions, you will find that the machine code are identical. So here, Intel syntax and AT&T syntax are just two different representations for instructions. They are equivalent. I don't want to get confused in this semester, but you can also tell which syntax is using by looking at the style of the instructions. As you see, for Intel syntax, registers doesn't start with a percent sign. However, for AT&T syntax, there is a percent sign, but also it has a more specific representation for move instructions. Move Q means that this is a move instruction with 64-bit movement. Here I'm going to show you more instructions that are written in Intel syntax, since we will be having to use Intel syntax rather than AT&T syntax in the majority of the course. Also, I'm going to show you operands in different fashion written in Intel syntax. There are different kinds of operands. Operand can be a single register or an immediate value, such as RX or just 0. Operands can also be a memory referenced by a register, such as keyword pointer RCX. And that means that we want to reference the memory with the address of the value of RCX, and the length of the memory they want to access is 64 bits, which is keyword. There's also more comprehensive representation for memory reference. We can use a base value plus an index value plus an offset, which is called BIS, to represent a memory. We can see from the last move instruction, the second operand, dword PTR pointer, RBP plus 4 times RAX minus 48. This operand represents a memory that with the base of RBP plus the index of RAX times 4, and then minus the offset of 48. So combine this together, we have a more comprehensive way to represent a memory that we want to access. And let's look at this last operand, spend a second, and think about why we need this. Or say, let's come up with a scenario that this kind of representation will help. All right, so here's an example. Consider that we have a local integer array. In this local integer array, we want to index it. And here, if we have this nice representation, we can use RAX to index the array, and we can use RBP minus 48 to represent the start of this array. In this case, if we want to move the value from the index of the array to another variable, this move statement will suffice simply. So far, we have talked about push instruction and move instruction. Now let's move on to the next one. The compare and conditional jump instructions. I like to talk about these two instructions together because they're usually used together. These instructions are written in Intel syntax. In this set of instructions, it means that if RAX is greater than RBX, then we're going to jump to somewhere. CMP means compare, and then JGE means jump with greater or equal to. Now you can see the advantage of using Intel syntax. Although for move instructions, the moving flow is counterintuitive. Here, if we do compare and conditional jump, it actually follows the flow. It will compare RAX and RBX using the symbol that was indicated from the conditional jump. So here, because this is greater and equal to, we're going to have RAX greater and equal to RBX. And then here, this is the destination of the jump. If the condition is satisfied, it will jump to that destination. However, if we use AT&T syntax, it's going to be counterintuitive. So if we use compare, if we have RBX and RAX, we actually need to flip them for this next conditional jump. This is the part of the reason I personally prefer Intel syntax than AT&T. Although different people will have different preferences, so go for whatever you feel comfortable with. And again, you don't have to guess which syntax that you're reading. You can tell by looking at the representation for the mnemonics and registers. Now we have covered multiple kinds of instructions. As you can see, most of them start with the mnemonics followed by operands. But actually there are variants for that. Prefix can be added at the front of an instruction. Not all instructions can be added with a prefix, but some of them can. Also, there are different kinds of prefix. Here, I'm going to talk about only one of them. This one that I'm going to show you is the prefix called rep. It means that the instruction will repeat until a condition is met. And specifically for rep prefix, it means that the instruction will repeat until ECX is equal to 0. And the reason why ECX is taken into account is because historically, ECX is used as a counter register. Okay, let's look at this example together. In this example, we'll assign a value to register ECX. And then we start to move the bytes from the pointer of ESI to the pointer of EDI. And this move instruction will repeat until ECX is equal to 0. I hope that this is a nice review for you or a start if you haven't learned x86-64 before. If you do just start, it's fine. I have some tips for you so that you can learn the assembly quickly. I like to use this metaphor saying that learning an assembly language or say learning any kind of programming language is similar to learning a foreign language. Like you want to learn French or you learn Spanish. So you don't have to learn all the instructions, although it's nice for you to know as many instructions as possible. This is like vocabulary in a language. Of course, it's nice if you have a large vocabulary, but if you don't, that's also fine. You can use instruction references as your dictionary. So if you have any mnemonics or any instructions that you don't know what it means, I highly recommend you to look it up so that you will understand it now and in the future. Also, I highly recommend you to read more assembly or say disassembly. Getting those is very easy. Write a simple C code and then compile it to assembly code. If you're using GCC, you can do GCC-S. If you don't use GCC, you can also check the options of the other compilers because usually they have this option. For x86-64 specifically, I have some useful resources for you. As I mentioned, instruction reference is very important because you're going to use it as your dictionary. There are many different instruction references, and I personally prefer one that is simple and easy to understand. I recommend this link to you as the information there is quite straightforward. Also, I recommend you to go over this cheat sheet because the cheat sheet covers the majority of the content that we will come across commonly in our course. Anyway, this is what I have for x86-64 Assembly 101. If you have more questions, feel free to Slack me or ask me questions in office hour or during the class. I will see you over there.